Hello guys, welcome back. Now in this session we are going to look into a step 2, that is univariate analysis. So in this aspect we are going to analyze our target variable as well as the predictor variable. Within the univariate analysis we are going to analyze various things based upon their type. If it is a continuous variable, then we are going to analyze that how our data is distributed, or say how our variable is distributed, whether it is positive skewed, whether it is negative skewed. We will also analyze the kurtosis for our variable, and then we can identify that whether it belongs to mesocortic, lepotocortic, platycortic. If you don't know about these concepts, then I will request you to please visit part 2 of this course, where I have explained in the descriptive statistics session all these concepts. Anyway, so let's proceed further and we will start the univariate analysis with the target variable. So first we will analyze our target variable, that is sales price, and see all the required statistics of the target variable, that is sales price. So we are into the Jupyter notebook, and here I am going to mention that we are going to do univariate analysis. So let's start with the sales price, that is our target variable. So here I am going to specify that data frame, and over here I will mention sell price, and then I will use, there is a method called describe, which will give us the information about count of sales price, what is the maximum value, what is the minimum value. It will also give us the mean information, standard deviation information, along with the percentage distribution information. So let's run it, do shift enter, then we will find that we have total number of record, that is 1460, and we are having the minimum value is on which the house sold, that is $34,900, and the maximum price of the house is $755,000. Along with that, it is also giving us information about the mean as well as the standard deviation about the sales price. So guys, this is about the count and the range information about the target variable. So guys, let's proceed further. Next we need to analyze that whether our target variable is normally distributed or not. We will also check that whether our target variable is positively skewed or negatively skewed. Once we draw that plot, then we will discuss about the significance of each of the things which I have told you, that is significance of normally distributed data within the target variable, significance of the skewness within the target variable. So let me write the custom function to draw the plot, and then we will discuss. So this is the custom function I have written, and it is based on the same concept which I have taught you in the previous part of this course, where we have learned about data visualization. So I have written comment over here also, you can go through it. So this line, you are already aware that whenever we are going to create any kind of a plot, we first need to create the figure. So this is the line, it is creating the figure. In the second line, we are creating the grid space, that is for 3 columns and 3 rows, as we are going to create 3 plots in a single figure. Then this line, you are also aware that we are going to add the subplot so that we can draw the histogram. This is for the second figure. There is another type of plot which we are going to look into, that is QQ plot. That is very important. This QQ plot will help us to identify that whether our data is normally distributed or not. Now coming to the axis 3, in the axis 3 we are going to plot the box plot, and this is the generic function which we can use for any kind of univariate analysis for any of the variable, whether it is a target variable or whether it is a predictor variable. We can use this function for any of the variable type, but currently we are using it for the target variable, that is our sale price. So now let's proceed further, press B, and over here we will get the new cell. So this is about the function. One thing I can also wanted to let you know, that is I have also imported some of the library to do the plotting. Over here you will find that I have imported matplotlib.gridspec, which you know that it is used to specify the grid specification. And then here we are using the SciPy library, and from there we are importing the stats model. And at last here we have used the style that is called 538 to display our plot in this style. So now let's run it. So to run it, we need to go to this cell. Let's load this function into the memory, and then we will write the code to call this. So we have loaded it. Now let's call this function, copy this one, and over here I will specify data frame, comma, and here I will pass the feature name. Feature is nothing but a variable. So here I will specify the variable name, that is sale price, and I will do shift enter. and once we run it, then we will get the output. And over here it is giving us three kind of information. The first one in the form of histogram, the second one is this is the QQ plot, and the third one is the box plot. So now let's talk about what is the significance of all these three diagram, or say all these three plots. So these three plot is giving us three information. The first, our target variable sell price is not normally distributed. Second, our target variable is right skewed. And third, our target variable have multiple outliers. So guys, you must be asking that how do I come to know that our target variable is right skewed, our target variable is not normally distributed, and our target variable contains the outlier? So to answer your question, if you closely look into this plot, then you will find that here the histogram is right skewed. So that means our target variable is positively skewed. So you must be asking that what do you mean by positively skewed, and how my target variable is related to the positive skewed data, how I will read it. So to answer your first question, in positive skewness, the mean and the median will be greater than the mode, similar to the plot which we are seeing it over here. Now coming to your second question, your target variable is positive skewed means within the given data about the houses, company has sold more houses in lesser price compared to their average price. Now this is about the histogram. Now coming to the QQ plot, so this will be used to identify the normal distribution within the given data. So over here within the target variable, if it is coming on the line to the red line, then it means that our data is normally distributed, and here in within histogram the shape will be in bell curve, which I have already explained in one of my session. But within this example, if you will see that this blue line is deviating from the red line, so it means that our data is not normally distributed. Now if you talk about the significance of the normally distributed data, then I need to discuss about one of the predictive model, that is linear regression, which we generally use to solve such kind of a problem where we want to do some forecasting on the basis of the dependent variables, or say predictor variables. So this predictive modeling technique, that is linear regression, expects that the dependent variable, or say target variable, to be multivariate normally distributed data. If this criteria is not fulfilled, then linear model will not give us the correct result, and because of that we will not forecast the correct sales price for this particular example. So now the next question you must be asking that, okay, my data is target variable is not normally distributed. So how I can make this data as a normally distributed data? Then I will tell that is another part of the story, but I will cover it over here. So in that scenario, we need to transform. So let me transform it, and then we will draw the same plot. Then you will get the difference between normally distributed data and not normally distributed data. So I need to transform the target variable sell price into natural log. So how I will do that? Here I will specify df, and here I will tell sell price, and then I will tell np.log1p. This is the numpy method, and over here I will specify df sell price. So once it is being done, let me copy paste this code to draw the plot again. So over here I will specify it. Now let's run it. Now let's look into the difference, and over here you will find that with the help of this natural log, we are able to convert our target variable into a normally distributed form. And over here you will see that our QQ plot is aligned with this red line compared to the earlier plot. If you will see into the earlier plot, our data is rightly skewed, that means it is positive skewed, and our QQ plot is deviated from the red line, and this box plot contains a very large dot, that means it is representing the outliers. We are having some cases which is deviated from the normal data range, and with the help of this transformation we are able to make our data normally distributed. So guys, now I have done with the target variable univariate analysis. Now we will proceed further and we will do the predictor variable analysis. So as we already aware that we are having two types of predictor variable in this case, where we are having categorical column and the numerical column. So first we will analyze the numerical column predictor variable, then we will analyze the categorical column. So if you go by the analysis for predictor numerical column one by one, then it is very much space consuming. So we are going to look into another approach by which we can draw all the plots for each of the predictor variable, numerical variable category. So let's do it. So we are going to grab the index of the numerical column. So I will tell that numeric underscore column, and over here I will specify df.dtypes, and here I will specify the condition df.dtypes not equal to object, and then I will mention index. Once we get that, then we will tell that I want to remove the cell price. So for that I will tell numeric call, and I want to remove the cell price as it is a target variable. So here I will tell numeric underscore call dot drop, and within drop method, which thing I want to drop? I want to drop cell price. So I got all the numerical column without cell price. Next, we need to also get the index of the categorical column. So how we can do that? We need to specify categorical underscore call index, we can tell, and over here we will specify df.dtypes, and this time we need to select the object type. So df.dtypes equal to object and grab the index. So we are done with this step. Now the next step, we need to draw the plot for each of the numerical predictor variables. So how we can do that? Let's look into that. First run is shift enter. So many typo we have done. Types, here it is types. Shift enter, done. Let's proceed further, and this time I am going to use something called pd melt. So here I will create a variable f pd melt, and over here I will specify data frame, and I will tell all the features that is numerical which we have created, numeric underscore call. So I have specified value vars equal to numeric underscore call. Once it is being done, now I am going to draw the graph for each of the numeric variables, and over here I will specify g equal to sns dot faceit grid, and over here I will specify f comma, and I will tell column I want to tell it as variable call wrap. I want 3. Make sure that this is outside. Call underscore wrap equal to 3 comma, there is a parameter called sharex. We need to tell it false, and then we need to tell that share y equal to false, and size I am going to keep it 5. Next we need to specify g equal to z dot map, and here we need to specify the plot, that is the actual plot, test plot, and over here we need to specify the value, and at last we need to tell that plot show close it. So now let's run it and let's look into the output. So let's press shift enter. So once you execute it, then you will find that it has given us all the predictor variable information like id. Don't bother about id because it is not useful, but over here you will find that we are having ms subclass, and if you look into that, it is also right skewed. This most of the data is right skewed. You will find that some of the data is at left skewed. We are having bimodal. This is mass van area. We are having rightly skewed data, and if you closely look into that, most of the data is rightly skewed, and you know that how to transform that data into a normally distributed data. Yes, correct, we need to use the transformation. We can use the normal log transformation so that our linear model in the predictive analysis will work properly. So now I hope that you can easily read these plots with the knowledge which we have applied on the analyzing the target variable in the earlier plot. So guys, this is about the predictor variable that is of numeric type. Now let's do the univariate analysis for the categorical column, as we have already bifurcated or segregated the numerical column as well as categorical column, and we have grabbed the index. Now let's draw the plot, and the plot is going to be the almost same. We just copy this one and paste it over here, and instead of numerical column I am going to specify the categorical call index over here, control V, and instead of this plot I am going to use the count plot, as count plot is used to plot the categorical data, and all thing is going to be same. So let's run it. Shift enter, then you will find that it has given us the count plot for all the categorical variable. So this you can analyze that this is the count plot for each of the categorical variable. So guys, the count plot of the categorical data show the number of different categories for each of the variable and their frequency distribution. There are variables where the different categories occur with the similar frequency. For example, if you look into this variable LA, that is almost similar frequency it contains, and there there are categories which is very dominant to the other category. If you talk about that variable, then if you take this example, MS Joining, which is very much dominant, this utilities, you will see that it is pretty much very dominant, as other one is not having any data. You can also verify this through the code. Over here you need to specify, for example, I am going to use LA, and there is something called value underscore counts, so it will tell us which value is having more count or which value is having less count. So that means it will give us the number of values. So shift enter, then you will find that the gravel is having 50 and pave is having 41. Copy the code. Let's check for the utilities. If we will specify over here utilities, shift enter, then you will find that it contains, all pub contains 1459, and for no saver it is 1. So all pub is more dominant. So guys, this is what I wanted to demonstrate you in this session, and this is about the univariate analysis which we have done for target variable as well as predictor variable in both the category, from the numerical data as well as the categorical data. So on this note, I am stopping over here. In the next session, we are going to discuss about bivariate analysis. So see you in the next session. Till then, bye bye, take care.